now we're going to start the panel discussion. Fresh water, energy, and raw materials are among the fundamental commodities required to maintain the sustainable development of Earth. So we just got a great introduction to the topic of sustainability by Nahla. Thank you. So what do you think is the contribution of your daily work to this topic?
Yeah, I think I have, I can see at least two contributions. So first, I work as a technology specialist at Novozymes. So my task is in principle to screen for new technologies and then also implement these technologies in our production sites. And there the focus is of course to make our production more efficient, and their sustainability is also a very important topic. So how can we get more out of our production with less resources? How do we save water? So this, I think, is my contribution to make our production more sustainable. And then as another point, I would say is Novozymes products, also the enzymes itself, they are helping to make the world more sustainable. So enzymes, they make, for example, make it possible that we can wash our clothes at 30 degrees instead of 60, or you produce bioethanol from enzymes so that we can get rid of our fossil fuels. So in that concept, I would say that as an employee of Novozymes, I help getting the enzymes out and contribute to better sustainability there.
Yeah, I think actually I tried to kind of tackle this question a bit during my presentation. Generally, I think one of the main things, of course, as a chemical engineer at the end of the day, is to optimize our process. As also, Holger, you mentioned that we have to find a better maybe substitute from the membrane that we use maybe for more than 20 years. And besides that, of course, making the optimization in the process operating conditions, going with maybe membranes, talking about the membranes that these days it has been produced to work with a lower pressure, for instance. So those kind of actions are what, from R&D point of view in Arla, we are also trying to tackle, besides all the research that we do to find other alternative membranes to apply for those different applications we have. So, and of course, it's another part is the SIP, that we have to also find out a better way for cleaning our membranes. We just have a small talk now together with Nahla. So yes, that's it from my side.
Yeah, I would love to imagine that we are not actually have a specific industry, but we kind of the police officer of the sustainability initiatives. And it's great that both of you working in optimization and reducing the carbon and water footprint. But I think in mainly like our role as sustainability analyst is to discover new ways other than optimization. And I think, Holger, you mentioned a very valid point in your presentation, saying that now the trend is not the sustainability work within the operation of a specific company, but it's extending to the value chain. So we have the downstream and the upstream. So it's important that, like in our work, we just try to hint and signal to the management that optimization is a good step, but also what can be done in ahead of that, yeah.
Waters is often between, in our case, between wastewater and processed waters. We just discussed that earlier. So the value chain is not only being observed, but it's also it's moving, it's dynamic. So it's the question of, is that water stream, is it wastewater already, or is it still usable, valuable water, for example? Mm-hmm. So this, to have the focus broadening a bit and taking the whole, I mean, basically it's a water, food, energy nexus, right? We're working in. I missed that word in our discussion. Yeah, to having the overall optimization and not only the optimization in a very specific application.
I actually thought about this question a bit because it's actually a very interesting question. In particular, because what like right now, if I want to say no, I do not agree. But looking from the like progress that right now we have towards different type of membranes, I agree that maybe in 20 years or so we can use most of our technologies, most of our process steps by membranes. Saying that, I think one of the challenges that I can see in membrane is when we go with the very high concentration streams, just before, let's say in our work, with just before the evaporation, we actually have a problem to increase the total solid content, or when we are working with a very high viscosity. We can see that there are still some challenges, that it's a bit limited what is existing right now in the membrane forum, but in many other things, like even the evaporation so-called, maybe there are some limits that I would say membrane still needs to go on a bit more to be fully actually applied at the end of the day in industry.
So I think I probably agree from a technical perspective. So I think you can, without knowing all the details about all the new membrane processes, I think you can do a lot with membranes. And you can probably find a unit operation and design a process that can replace also other unit operations which are maybe not as at first glance be a competitor to a membrane system. From an economical perspective, I don't think that this is correct. So you will probably use much more investment costs, or it will be more demanding to run the process in the way to produce the same quality, for example. On the other hand, I don't think either that this should be the goal, to replace all the unit operations that we have with membranes, because all the other processes that we have, like centrifugation, chromatography, they have their right to be there, and it's good that we have all these choices. And then I see that more as maybe also a little bit provocative argument or a statement to show what actually membranes can do, but not necessarily that we should work towards replacing all the other unit operations with membranes.
Yeah, I was about to agree about the economical perspective, and there's a third perspective, namely the ecological perspective.
Yeah.
And that's often, but not always, related to economical drivers. So yeah, fully agree.
Yeah, I just want to add that maybe it's of course we are talking about the application of membranes, but it's also that we have to go a bit more further on the membrane, that they are, as you mentioned also, that when we have to dispose all of those membranes that we are also using, we have to also think about that part of the story. Let's assume if we are going to use every steps of our process only using the membranes. I totally agree with Holger that at the end of the day, it's not about the membrane, it's about our environment, it's about our world at the end of the day, and whatever that comes in the calculation wise, that it's greener or it's make more sense for the human. I think that's the choice at the end. Even that I am working for more than 10 years in membrane world, I think still we should not be biased because the membrane is the best because I work with it.
Yeah.
But the selectivity is the real added value from membranes. So at least in our sector, that's real added value also with regard to recovering resources. So I would go for maybe a bit provocative, but I would go for the selectivity.
I think it's very dependent on the application. It's a good answer, always. No, I think if you have, for example, a low-cost product that you need to treat or produce, then I think capacity is very important. If you have a low capacity, and fouling, of course, also, because that's related to capacity. If you have then low capacity, then you will just not compete with a membrane, since your installation cost will be too high. In the contrast, if you have a high-value product, then capacity doesn't matter. I mean, it matters, of course, but okay, then you just put more membrane area inside. So this is, of course, a price you have to pay, but you are willing to do that. But you cannot live with a bad selectivity in that case, because you will not produce your product in the quality that you need. So I believe that that it depends a little bit on what the goal is, but if I have to do a ranking, then I would also say selectivity is more important than capacity, because capacity you solve by money.
Yeah.
I just wanted to say I've 100% agreed. It was just here. I said the same for product at the end of the day. So I have nothing more to add. I think you said what I thought in mind.
Well, I'm not the membrane expert here, but I just would like to add from what I saw from the amazing research everyone is doing here, that besides this factor, it's important to look like if you proposing like energy interventions, so like cooling or heating, like some of you do, also just look into the overall environmental cost, because it doesn't make sense if you have a high functioning membrane but it's using a lot of energy, hence, and then emitting a lot of carbon emission. Yeah.
I'm still thinking of it, because it's always a challenge when I join any conference. It's always the case that it's exactly kind of similar to what you see as a percentage, that in particular talking about the food industry and food application is getting almost diminished when we go to the different conferences related to the membrane applications. But I think in general, it's good that we are working on this surface modification, and it's very nice. But in my view, it's not anymore one or two applications. It's not anymore one, let's say, produce the membranes. What I think is what could be better is that we have to go one step further. Okay, I want to produce this membrane. It's very nice. Yes, bravo. But what is exactly your goal? I think that is where I see the problem starts. That we just have 40. Let's say I have 40% in this statistics that is going for development, but I don't see that number when it comes to the bigger scale from the industrial point of view when I have the talk with the manufacturers. And that is a part that I see it's missing, maybe because we are not focused in the application we want to use that membrane that you produced. Maybe it's also a part that our young researchers, maybe including any of you that works with it, you have to consider exactly where you want to stand at the end of the day. We can't make a membrane that can be used for food industry and then goes also maybe for wastewater. Maybe we have to be more interdisciplinary science to consider, but also the application. Just to add on that we produce the membrane and then maybe I come and ask, okay, but in the food industry, you have a problem of the carryover. You have to consider such kind of application. Just look at it a bit ahead, that could be a problem. So when you are making your membrane, consider what you want to use it for and what is important to consider when you are producing that membrane or making that development. I see that is at least from my point that I'm working with application, the whole that I see in between of these two areas.
Yeah, I agree. Maybe I'm asking for too much, but the question should not be what is technically or scientifically feasible, but the question should be what do we actually need, yes, and is there a way to do it? And if there's not a way to do it, then we will find a way. Yes. But my impression is also that often enough the perspective is coming from what can we do in the lab, and then we find another solution for it, maybe, or an application for it, while the idea the question should be, what is the problem we want to solve? Yes. But maybe it's maybe it does make sense to come from both directions, and we meet in the middle.
I agree.
I don't think that we should say that one research is more important than the other. I feel a little bit that we need all of them, and what as I see it, at least, for example, membrane characterization, that is important because you increase the understanding of problems that we have in industry, and that knowledge is of course valuable because it gives us some tools to solve them. And similar is also, I think, application research. And then if you look more into membrane development, there you maybe not increase our know-how, but you offer some possible groundbreaking technology for the future, so which opens up new ways of producing. So that's also important. So I think it has different aspects, these three fields, but I don't find one more important than the other.
Sorry, just something popped up in my mind. I talked to a wastewater guy a couple of months ago, and he said if it's good and if it's working and if it's efficient and if it's economically feasible,
Right.
then it's already done. So there's no need to do research anymore because we know what's good, and if it's not been done yet, then it can't be good. So that's that's the perspective of some of the gray-haired guys and on the wastewater plants, but I think to some extent that's true, but boundary conditions are changing. So what hasn't been economically feasible maybe 10 years ago, 20 years ago, could be economically or ecologically or socially acceptable in 20 years. So I think it's a good comment from him, because it makes us think about, okay, are we developing stuff in a box that never can be used? But boundary conditions are changing and drivers are changing, and I think that's exactly what we should keep in mind when developing things. So some of the inventions being made today might look very theoretical from our perspective now, but they can really add a value in 10 years from now or so.
Technology that is just we use for membrane characterization is one of the examples that, you know, how much advanced technology came in, you can add on that. That is one of the cases that when we talk about the membrane surface and how it's changed, and to understand that it's quite difficult to, it's quite difficult to justify it sometimes. So I think you are totally right, Holger. I totally agree with you, actually.
Exactly. So if you would redesign your membrane processes, what would you do differently now? If you, like, with the knowledge that you have now, so looking back at your processes, do you think there's something, or maybe you, Holger, you redesign on the, okay, no, I mean for like your
processes in production, they're perfect already.
Yeah.
Exactly.
Yeah, but I mean, because you're working in the pilot, so I guess you adjust your processes all the time. But I don't know about you, Behnaz. Is there something that you think you would like do differently now, if you would start from scratch?
I mean, I can't say what I can change, but at the end of the day, I am in the research and development. So I can say I have my ambitions. I want to change. I think I also mentioned some of the goals or ambitions that I think I have a very great support from R&D in AFI, in Arla Foods Ingredients, that we want to change, we want to do better. I think what is right now, if you really look at it, of course I complain, but really it's nice. It's really consider all the different aspects from the water point of view, from the energy. But I would say it's bravo from what has been done so far, but I think from where I'm standing, from what has been in all the research and development, I think we can do better. And that means that, yes, we should optimize our system even better. I actually mentioned about the inline or digitalization you also highlighted. I think that could combine with the membrane technology to achieve even better yield or productivity at the end of the day. And of course, we like to reduce the energy and waste that we produce even more. So I would say there are a lot of things that we can do better at the end of the day. Maybe I don't change it because I think it was good at the end. When I'm seeing, it's really nice, I have to say. So.
Yeah, I would say from I really like the idea of minimizing waste from a production process. So recirculating as much as possible and treating waste streams and reuse the streams back in the process. And that I think there is a lot of potential that you can do, which we are also not utilizing today. And that is something that I think I would probably love to work on more. And then maybe a second point is if I think about our membrane systems that we have in our productions, some of them are very old. Some are a little bit newer. And if I think now about sustainability, then at that time when they were built and constructed, their sustainability was maybe not the most highest focus point. And as you find in the design of the system, that they have maybe a large dead volume, or they are, from a design perspective, not ideal regarding energy consumption and so on. And there you can, of course, do a lot already by thinking sustainability into the design of your system. And also for when you control, if you write the control or program the unit, the control of the system, there you can gain a lot by doing that well. So save water by optimizing your controls and so on. This is also something that where you can improve on even existing systems, I would say.
Okay. So I would like to add something. You said now digitalization, and you mentioned it also in your presentation. What is the digitalization you're thinking about? If like digitalization is such a broad word, we hear it every day, I think. Was like something specific that you think about?
Nothing specific, but I think it's in the water and wastewater sector, we're referring to digitalization with regard to, obviously process monitoring and improving not only the operation of processes, but also the maintenance of processes, looking at predictive maintenance and that type of machine learning stuff. And this is becoming more and more important as we're having more decentralized systems, and that also applies to industry, looking at mining sites, looking at oil and gas platforms. The more decentral things get, the more scarce the resources get, the more decentral we get, and the more decentral we get, the more we rely on digital solutions to not only to operate but also to maintain things.
Maybe I will add that, for instance, we are actually also working, another colleague of us, in collaboration with the KU University in the Copenhagen, the university that actually we like to go more inline methods, measurements for different applications. For instance, let's say we use a lot of water and energy when we are cleaning our membranes, and sometimes maybe it's not the most optimal way we do it. Maybe we overdo the cleaning, in particular in food industry. It does matter that we kind of be sure that everything is completely clean and we don't have any, let's say, danger of the carryovers to the membrane. We are doing excellent, but to be able to optimize such kind of process, it's actually quite interesting if you have an inline measurement that you are sure about that, let's say, the total solid and so on, to be able to stop your process in most optimal way. Besides that, is the same. I explained a bit about the off-grade issues that time to time it may happen, and sometimes it is good to act faster. So basically, if you have an inline method measurement, let's say you can fraction the different proteins and the ratio that you like to catch always. And if you know this inline measurement technology, for instance, in a correct way, you have, of course, a lot of data and you validate your data and you have to do your calibration. Yes, there are a lot of challenges to implement, but it is very good. Then you can act faster. Before that you finish all the process and you waste too many things, you can stop it in advance and don't maybe or reduce the amount of resources that you have already used. So that is where we are actually using quite a lot in controlling the system with the pressure, temperature, and all this. But even further, I think it's actually quite something that we are working on it to be even better.
Okay. Then we have another quote in a feature article called "Technology Trends in Membrane Filtration Membrane filtration use," published in Filtration and Separation in 2018. They mentioned that water and wastewater treatment account for more than 50% of the industrial membrane usage, followed by food and beverage processes, which is like 21%, and pharmaceutical and medical applications, which is 9%. I think, we covered. I think you have a good representation here. But what do you think, are there other industries that you have in mind that could use membranes much more outside of your field?
I just came to my mind the pulp and paper maybe process. That was also something that it has been used. I don't know, maybe that is in other percentage of that it has been mentioned, maybe, but that is just the one that it at least came in my mind for being able to use maybe membrane even more. Let's take it.
Yeah, I had also forestry or pulp and paper industry in my mind, and I think also oil and gas, for example. That's maybe not the future, hopefully, but anyway, they can also clean up their mess a little bit better by membranes. Eventually, also energy sector. There are also membrane applications which you can use to produce energy. Actually, that's also something which I could imagine could be evident more.
Yeah. Chemicals, organics, inorganics, fertilizer, and the question is where does, as I said earlier, where does the process end and where does the waste stream begin? So. Yeah. Especially for oil and gas and for mining, I would say, they're having huge, highly contaminated waters, and they call it produced water, but it's basically wastewater, which is the opposite. So yeah, I think borders are shifting, especially in these heavy-duty industries.
Yes, I guess the challenge for chemical industry is that they have already really established processes, so it's only if they build new ones that I assume why they are not there. Yeah. Yes. So then we have a thought from Frank. He's usually saying that if applied properly, then membrane processes contribute to all of the 17 Sustainable Development Goals. Yeah, we've talked about this with you during the poster presentation. Do you think that's correct?
I looked through these goals, and I think there are certainly some no-brainers where membranes can help, like better, higher quality water, and less food waste or no poverty and things like this, where I can really see a point. And also like peace, I think, is also where membranes can help, because I think today there are wars fought because of lack of water, and I think there I really agree. Then there are a little bit more maybe social or society related goals, like gender equality and good education, where I don't really see a relation with membranes, to be honest. But I would say I totally agree that the largest part of the goals membranes can contribute.
Yeah, I spent quite time in this question. Yeah, I agree with you, Holger. It's difficult to see the social impact of membrane, but I just remember like one case study from the oil and gas sector in Sudan. They, in one of the companies, that we have a lot of oil in Sudan, and one of the company working in the oil refineries, they came to village that has a lot of oil reserve, and they were trying to do social responsibility. So they built a school because they thought like there's no school in the town there, and so they wanted to build a school. And they built the school, and it was a nice school. But then no one got to school. No one went to the school, although it was free and it was has a good facility and so on. When they tried to investigate why they did so, they hired a colleague of mine, and he went there and he found out the main reason like children don't go to school is not because their parents don't want to, but their parents send them to like far places to get some water. And when they investigate why they don't have water nearby, they found out the water treatment is very poor. So the oil company has then invested in like water treatment plant membrane, and like children then went to school, and it's indirect relation, but you can see like the relationship. So I mean, it's a bold statement, but I can see the relationship. And the peace goal is, I can see it also in my hometown, where I said like UN said Darfur is the first climate change war. I mean, like if we had membrane there, it wouldn't solve the war or like end the war, but it will definitely help in creating solutions. So yeah, I do agree.
So we'd like to ask you, what do researchers and scientists need to do to inspire others to shift towards a more sustainable approach for existing processes?
Yeah, so what I think is like the huge challenge and also like the opportunity for sustainability research is that like how we communicate the research finding to industry and also to the society. So for example, in the life cycle assessment we do for product and services, it's a lot of scientific research is done there, but there's a huge gap to encourage other researchers to work on it. So one of the main things that, for example, incentivize the research and industry is how you communicate the numbers and the needs. So, for example, like what I did, for example, in the presentation today, showing the social aspect of it, showing the numbers, showing the urgency in the issues itself. I think this is very important, and also just trying to simplify the need, like why we need this, and also I think the other thing is, we don't really know the impact of what we are doing, and we need to know that, because I mean, like we're doing a lot of, there's a lot of innovation happening, and the innovation cycle are very short. We don't know what new technologies are contributing to or against the climate change. So I think this is a really great point to just attract more researchers to see the climate change aspect of innovation.
So what I had in mind when I read the question is also that I see a little bit in all these sustainability targets that the companies and also the governments put, they are based on knowledge from academia, what is technically feasible. It doesn't need to be economic at that time, but the goals and the regulations, they are set based on what has been shown is technically feasible. It's of course ambitious goals, because there shouldn't be a solution already completely there, but I don't think that the goals are made out of a blue, like okay, now I put a target and we have no clue about how to do it. So I see a little bit the academia and researchers' task is to show what is possible with technology, because if you can show with your research that you can actually improve a process in that way and make it more sustainable, that will probably be the basis for the newest regulations or the regulations in the future and the goals for the future.
It was just to say, add on that when I started maybe 10 years ago doing my PhD, I really did not have this broad perspective in my research time. I was focusing only on doing the research. But I think actually when I moved, and I was very proud, I used the membrane and I could concentrate perfect. But really later you notice that what you did is not necessarily the best solution. When you just start to do the calculation of the CapEx and OpEx and all this, you actually notice that you didn't see this broader perspective. And I think I'm very happy with these talks and all this focus that we are putting. I think most important part is to be aware. I think awareness is the first step to be able to change something. And in my view, the science part is one step. One of the pioneer, they should be one of the pioneer to think before they even come with a solution that they want to apply. Always.
My advice is certainly that that even though membranes are cool, you should not. I think it's also important to keep the eyes and ears open for other technologies and consider them too, because it doesn't help to put everywhere membranes and then they don't work. So I think this is also something to keep in mind. To look also for other technologies and then take the decision based on what works best. Yeah.
Okay, if I'm forced to answer, although I'm not working in the membrane field, agree. So that's more or less what I meant earlier, right? So the question shouldn't be what do I have, so and where can I apply it, but the other way around, what's the problem and how can I solve it? And if a sand filter works, then why should I apply a microfiltration? Maybe it's a bit rude because it's really the persistent topic in the water sector as well. We have all these things running for 100 years, so why should we change? And often that's true. Often it's good as it's running, right? But there might be might be other applications, but the question should be how can I solve it and not what can I solve with with what I have.
Thank you. I think that fits really nicely to what we've seen actually during the last days, where we've seen many membrane processes, and we've seen that it's not only membranes that is important, it's always like the pre-treatment and the post-treatment, and there's so many different processes, unit operations involved. So I think that's a really good, consistent that you say it now, that we should not only focus on this one step, but look into others. Okay, so with this, we would finish, and maybe you have like a take-home message, if that is not the take-home message. Otherwise, you can rephrase it again one more time.
My take-home message, I thought now also what you said with these 17 goals there, how membranes contribute even to these social aspects. That was really nice to hear, because I didn't think of that. And I think this is a take-home message for me, at least. How many problems we can actually address with membranes, that's actually quite cool. Yeah.
Like, I really learned a lot from the speaker sessions today, but I think my greatest learning was from the young researcher here. Actually, I was very impressed by the excitement and the dedication you guys put. I'm really impressed. I'm also in the process of making my thesis for the masters, so I feel inspired by the work you are doing. I'm very, 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 very proud of all the work you have done. It's really amazing.
I have to say, of course, just today I joined you, and I think I'm a bit, my take home is that I should be, before coming also with you to other, to kind of come with more time to take with you, because I see that it is very enthusiastic society, let's say young society, which is really, really nice to see. And I hope I can see you later in your membrane or something, but I'm sure that it's gonna be, and I'm really hopeful for the future collaboration that we will have with all your ambitions that I can see around. So thank you for being ambitious.
My take-home message for you is that, as we said many times now, don't lose yourself too much on the focus. On the other hand, or keep economic and ecological feasibility in mind. But on the other hand, I think that came up as well, is that drivers and barriers are changing and moving. And as I said, things that wouldn't have been feasible 20 years ago might make sense in 10 years from now. So also maybe be a bit more visionary than I am. And the take home for me is that next time I will stay for the Euro membranes and won't leave early.
Yeah, so thank you very much for this interesting talk. I hope you also learned something and had fun. Yes, so we can give one more applaud for the speakers that we had today.